So hello everyone, I'm Damian from GuardSquare. I am an R&D engineer at our company. Most of you are already familiar with our open source tool ProGuard, which is where our company originates from. But nowadays we provide also security solutions for both iOS and Android. So today I'd like to talk about piracy in regards to in-app purchases. So maybe some of you are wondering, what is there to gain from piracy on iOS? Well, we had a look at more than 200 applications, and here's what we found. So $215, that's a cost of a yearly subscription to YouTube Music and SoundCloud. On the other hand, I could choose to install some tweaks on my device to get free access to those premium features of these applications. Tweaks under the hood, tweaks, they don't require any coding knowledge. There are even App Store-like alternatives, making them easily accessible to average iOS user. Under the hood, there are just libraries of codes that swizzle some logic, so there's not really much to them. So now I have a choice, either get some tweaks that will swizzle 13 methods or pay the yearly subscription. And that's just two apps. Let's add some more to it, like Adobe Photoshop, Bear, Evernote, some Duolingo, MyFitnessPal, Strava, so all everyday use applications. Just taking a subset of 18, there is a choice. Either get tweaks that swizzle 99 methods or pay $1,800 a year. So that's from user, of course. You can imagine what would be the scale of that for your applications, for your company. So what you as a developer can do to make sure that your users don't have this choice? So there are a few options. You can choose to rely on system security. You can try to do it yourself, or you can reach for a specialized third-party solution. So now for the first one, if you choose to rely on a system, you have to be aware of its limitations in this regard. So most of iOS security mechanisms are designed with user in mind, to protect user. For your application, the main line of defense is Fairplay DRM, and that is responsible for encryption of your application code. However, as long as it's possible to run your application on a jailbroken device, it will be possible to export decrypted application codes just to get access to it. And nowadays that's not a problem at all, because around 80% of active iPhones can be jailbroken, regardless of their iOS versions. And despite common misconceptions, jailbreak community is very active. They even managed to release jailbreak for iOS 13 much faster than they did for previous versions. So if somebody wants to look underneath your app, system just won't be enough to stop them. For the second approach of adding your own security layer, let's look from a more practical perspective. So this is a reverse code snippet from streaming application Twitch. Probably a lot of you are familiar with it. This is a piece of code where you check whether a user has access to their subscription service called Turbo. And as you might notice, they're using keychain there, which kind of gives you some false sense of security. But in terms of tweaks, it's not really relevant. Here's an implementation of a publicly available tweak that swizzles this very method and gives you free access to all premium features of the application. So with DIY solutions, what developers would often do is maybe add some jailbreak checks, reach for open source library, thinking that would be enough to stop users from using this kind of tweak. However, that's not really the case, because application can be repackaged and distributed and later actually run on non-jailbroken device, which is a bit more effort actually. What's often more simpler and more common is to just come up with tweaks that will make the security checks, neglect the security checks, and this is often how it's done, just with the application logic. So this just won't be sufficient. There's also the third option, where you can choose for a third-party solution. But for it to be more effective, it actually has to take off three of integrity aspects of your application, which is environment integrity. So that is the part where developers most often focus on with their DIY solutions. There's application integrity that verifies their application package hasn't been modified, there are no additional libraries injected, etc. And code integrity with similar goal but on a code level, because you want to make sure that code that is being executed is actually your code. And having all of these three aspects will also increase the effectiveness of all of them. Focusing on a single one just won't be enough. And this isn't even all of that, because those integrity checks happen at application runtime, so they can be worked around just as application logic is. What you need is a form of code obfuscation that will actually hide the implementation details. So code obfuscation will not only hide logic of your application, but also harden these runtime checks, making it much more difficult to work around. And also, reverse engineering tools are constantly improving. Techniques are also better. There are new jailbreaks coming. So taking care of your application security basically becomes a full-time job. Reaching for a third-party solution also takes the maintenance burden off of your shoulders. So this is the third option that you have. And we've covered the three aspects in terms of piracy, but there are, of course, many more threats that your application is facing. Here are some more examples, but there are, of course, not all of them. Like, for instance, fraud and cheating. I bet that most of you are familiar with Pokemon Go, where the application on its release was basically unplayable for the first few days because people worldwide managed to access the game, even though it was released only in a few selected countries. So that's just one simple example. So if you see here anything relevant to your application or anything during the presentation caught your attention, we would like to invite you to come talk to us, and we'll be happy to discuss it more in detail. Thank you very much.